So if I look at sine of 285, well, sine of 240 plus 45 is 285, right? So then that means if I use my formula, sine is sine, cosine, cosine, sine, as you see here. So it's a slightly different formula, but notice this time the signs stay the same. So it's sine, cosine, cosine, sine, cosine, cosine, sine, versus cosine, cosine, sine, sine. All right, so sine of 240 cosine 45 plus cosine 240 sine 45. And now you do the same thing. So let's see, 240, the sine value at 240 is negative square root of 3 over 2. Square root of 2 over 2. And cosine of 240 is negative 1/2. And sine is square root of 2 over 2. Right, so if I do that, then I get negative square root of 6 over 4 minus square root of 2 over 4, which means our final answer is negative square root of 6 minus square root of 2 all over 4. Ta-da! All right, now if we use that formula again, like how we did, for example, 2 and 3 for the previous type, let's see, it's sine, cosine, cosine, sine, and remember the signs don't change this time, so that would be the sine sum. So that means we have sine of pi over 9 plus 2 pi over 9. Well, if I simplify that, that's sine of 3 pi over 9, which simplifies to sine pi over 3. And what's sine of pi over 3 is, what, square root of 3 over 2? Yeah. Boom. All right, one more. If I simplify this using the algebraic expression, again, sine, cosine, cosine, sine, and it's being added, well, with the sine one, that's where they don't change. So that would simply just be sine of the first angle plus the second angle. That would just simplify to negative 2x. It said simplify the algebraic expression. There's nothing to solve for, so that's all we do. All right, verifying identities. That's what you did yesterday with trig proofs. Okay. So we want to verify the left-hand side equals the right-hand side. The biggest mistake people make here is they try to distribute. That is not a thing, okay? Because this doesn't read s times I times n. It's sine of an angle. So distributing is not a thing, okay? But what we can do is use our sum and difference formula. Since this is sine, that's the one that's sine, cosine, cosine, sine. So I'd say sine, cosine, cosine, sine. And then you keep the sign in the middle since it's negative. I say negative, right? So it comes from that blue box of the formulas, okay? So if we come back down here, well, sine of pi over 2 on the unit circle is 1. Cosine of pi over 2 is 0, right? So 0 times anything is 0, so you're left with cosine. Oh, would you look at that? We wanted it to equal cosine, so we verified the identity. All right, now applying sum and difference formula on the coordinate trig system. So it says cosine, we want to evaluate cosine of a plus b. So first I'm going to write out what cosine of a plus b is according to our formula. Remember, it's cosine, cosine, sine, sine. And cosine is the one where you flip it. So since it's plus, we say minus. Okay. Well, I have some of my information. I have that sine is 4/5, so I could plug in 4/5 there. And then I also have that sine is 1/2. but I don't have my other information yet. However, it said that sine was in the first quadrant. Sine of b was in the first quadrant. And it was 1 over 2, okay? Opposite over hypotenuse. And the other one was in quadrant 2. Okay, sine is opposite over hypotenuse. Well, if I use Pythagorean theorem, 2 squared minus 1 squared gives us square root of 3. And then the other one, 5 squared, 25, minus 4 squared, 16. 25 minus 16, that would give us 3. But since it's in the second quadrant, negative, right? And so cosine, remember cosine of anything is adjacent over hypotenuse. So adjacent would be negative 3 over the hypotenuse, 5. Cosine of b is adjacent, so square root of 3 over hypotenuse, which is 2. Okay, and now if we multiply these together, that would be 3 square root of 3 over 10 minus 4 over 10. Hey, they have common denominators, so you just simply write 3 square root of 3 minus 4 over 10. Okay, now if we did the same one for sine, well, sine is sine, cosine, cosine, sine. Oops. All right, sine of A is 4/5. Cosine of B is square root of 3 over 2. Cosine of A is negative 3/5. And sine of B is 1/2. So we what? 4 square root of 3 minus 3 all over 10. And that's how you use the sum and difference identities, okay? Now, our last one, double angle identities. Our double angle identity for sine 2 theta is 2 sine cosine. Cosine 2 theta is 3 different versions. And the reason it's 3 different versions is because if we just had the first one, that's fine, but then you can find the other 2 using your identities, remember? Remember that sine squared according to your Pythagorean identity is 1 minus cosine squared? Well, if we distribute, that would end up being negative 1 plus cosine squared. Oh, would you look at that? That's 2 cosine squared minus 1. And vice versa, if I plugged in sine, or for cosine, 1 minus sine squared, minus sine squared, according to your Pythagorean identity, well, that would reduce down to 1 minus 2 sine squared. Okay? So that's why there's 3 different manipulations for cosine of 2 theta, because it's like the Pythagorean theorem, or Pythagorean identities, I guess. All right, so if we look at this one, you know, sine 2 theta is 2 sine cosine. We have that this is in, since it's 3 pi over 2 and 2 pi, that's the 4th quadrant, right? Okay, and theta puts here, adjacent, hypotenuse. I believe that's 12, I want to say. Yeah, I'm pretty sure that's 12. And so that would mean that's negative since it's in the 4th quadrant, right? And so now we have 2. Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. I don't know what that is. That's something over 17 times 17 is 289. So whatever 2 times 12, which is negative 24 times 15, whatever that number is, negative, blah, that number. All right, so you get the gist. This is how you do identities. Okay, goodbye.